All right, good morning, everyone. Welcome to this presentation. So welcome to Optimum Solutions' final installment of our webinar series. Today, we'll be looking at economic time series modeling in MATLAB. My name is Malavika Nathan. I'm currently a solutions engineer at Optimum Solutions. I've done my BSc in electrical at WITS and my master's in biomedical at WITS as well. So just a few housekeeping rules before we carry over to the presentation. I'd like to make sure that everyone keeps their mics on mute. If you do have any questions, you're more than welcome to add them to the chat or hold on to them because we'll be having a questions and answers session at the end of this presentation. I'd also like to make sure that everyone keeps their cameras off to conserve bandwidth, and I'd just like to bring to everyone's attention that we will be recording this presentation. So let's go straight ahead to our presentation. And first of all, let's look at what a time series is. Let's jog our memories, refresh our brains, just a bit of a refresher. Then we'll look at working with time series data. Is there a workflow? How do we do it? And then go ahead into an example of how to work with this data, a demonstration to implement the solution, and then a few next steps that we'll be coming back for. So what is a time series? Well, the definition says it's a sequential numeric data points in successive order that depends on time. Simply, it's recording data every hour or every day or every month, and this form of data provides insight into the change of the prices of financial instruments over time. It could be indexed, it could be stock data, it could be commodities such as gold or platinum, or it could be the number of strawberries I eat every day. Essentially, we use this information not only to analyze my performance of strawberry eating, but to forecast or even predict this data into the future. But creating these models can be quite time-consuming and even difficult. Remember, it's easy for errors to creep in when we're manually coding most of this analyses. So let's look at working with time series data. Let's look at the workflow that might be the easiest to follow. First of all, we need a problem definition. What are we predicting? Is it gold? Is it strawberries? Once I've discovered that, I need to do a bit of preliminary analysis. Find the trends in the data. Are stuff missing? Is there cycles, statistical properties I need to remove? Once I've done all of that, I need to find the best model that describes my data so that I can finally evaluate it for my predictions. So where does the ease come in? Well, MATLAB makes both of these processes much easier. In terms of the preliminary analysis, there's multiple functions to help you with the maths and the statistics, and MATLAB is capable of producing some really good AI models as well. We have comfort in the fact that we're doing the right thing, and we know that MathWorks functions are quality tested and controlled. Let's look at an example. I want to forecast time series data, specifically S&P 500 USA stock market index data. And if I can I predict the returns? And if I predict the returns, does this prediction have the general behavior of the previous data? And if all of this is possible, what do I use? Which models are the most appropriate? And if they're appropriate, are they effective? Well, let's look at a demonstration. Being the distributors of MATLAB and Simulink, the platform that we'll be using to implement our solution will be MATLAB. So let's go straight over to our MATLAB over here. As I open MATLAB, you can see to the left my current folder. To the right, I have a workspace with all the variables that I've loaded when I've run the script. To the bottom, I have a command window as well. Just for the purpose of this presentation, I will be minimizing my command window and minimizing my current folder. At the top, at the home button, a home ribbon, you can see all these various points, buttons that are interactively helping you navigate MATLAB. Because I've opened the live script itself, the live editor ribbon opens up and you can see all these interactive buttons as well. Here in the script, there's not only text, but also hyperlinks. If I scroll over, interactive links from the table of contents, and over here I have code. If I go to the insert ribbon, I can even include images and equations. If you're interested in knowing how to work with live scripts, you're more than welcome to click these hyperlinks I've included in the script. At the end of this presentation, Michelle, our marketing specialist, will be sending a link for the survey, the evaluation feedback form, and then when you fill that in due course, you will also receive all the data, all the scripts, and the presentation itself, so you can run through it. So let's start the demonstration. Let's look at economic time series modeling in MATLAB. If we remember correctly, financial time series data can depend on previous lagged returns and innovations, right? So to capture this behavior, the best model are Arima models, also known as autoregressive integrated moving average models. Essentially, we're forecasting a time series data into the future, right? We're estimating the sequence of observations to continue into the future. But financial time series data also has volatility. There's those clustering behaviors that can happen. And the best way to capture this behavior is by using GOSH models, also known as generalized autoregressive conditional heteroscedasticity models. In this example, since we're looking at our S&P 500 index returns data to generate our forecast, we will be specifying and estimating Arima and GOSH models. So let's go right down and actually look at importing data. I need to work with data, right? So I need to import it. Well, MATLAB allows multiple ways to bring data into to MATLAB. If I just minimize this workspace over here, you can there's a hyperlink to help you go through multiple forms, or you can go to the current folder, right-click the file, for example, the CSV, click import data. If I go over to the home ribbon, there's an importing data clickable button over there, or I can use functions itself. In this instance, there's a MathWorks customized function. If I open it up, it uses the fetch function to bring in live data. We can even bring in live data. So basically, the data feed toolbox helps retrieve live data from multiple financial sources or data providers such as Bloomberg, FactSet, Thomson Reuters, etc. I wanted S&P 500 data, which is why I said all these variables from the 1st of Jan 2010 to the 23rd of February in 2020. When I plotted this data, if I open this up, that is, and expand it, I'm just going to zoom into this data, right? And you can actually see that there's these like broken bits. Well, that's because you're pulling in real-time data. Everything data recorded, it has unrecorded data, for example, days when there's no stock market activity happening, such as weekends, public holidays, etc. So remember, we have to keep this in mind when we're bringing real-time data. So for the interest of this presentation, I'll be using the load function to bring in a mat file from my current folder over here, smp500.mat, so that it even shows you that if you don't have access to the data feed toolbox, if you do have mat files or CSV files, you can still run this example if you don't have the toolbox. So let's look at our second step in our workflow, the data preparation. We're analyzing our data. Remember, we need to transform our data to stationary data sets. We're essentially removing the trends, the mean, the variance from the data so we can better perceive it or interpret it, right? In this instance, I'll be using the tick to ret function, which essentially does differencing. So I'm basically converting it to a return series over here. So I've differenced my data. I've also used the isNaN function to remove non-iterating data, the weekends, like the missing data in the weekends and public holidays, so that when I plot this data as a function of time or date time variable, I'm opening this up. I want to make sure that everyone's keeping their eye on this x-axis over here. Every time I zoom into the data, the axis actually changes accordingly. Here, it's now days and even hours itself. So MATLAB helps with plotting data quite granularly if you use datetime variables. To the bottom, I've also plotted the returns data, as you can see, and we've actually removed the trends, so it's quite simple over there. Now that we've done this differencing, remember, this process is known as difference stationary. So there still might be other possibilities in my data, such as unit roots, or the data might not be stationary itself. So we need to do a few tests to figure that out. But first and foremost, I need to split my data set and a testing set. So since we're looking at creating models, right, the Arima and GOT models, we need to split our data so that we can create our model, and then we need to test that it's correct, which is why I'll be using the two most recent years of the data as my testing set, and then everything remaining as my training set. So over here, we can see S&P returns data and S&P train data. Now what I've done is I'm actually going to run the Econometrics Modeler app. This is an interactive app that's available to you to look at the data and work with it. You can either use this command, open up the command window, enter it over here, and open the app itself, or you can go to the apps ribbon, scroll down all the way to where it's situated under computational finance. Now you can see that there's multiple apps available to me, but that's because I have all the toolboxes available to myself. So I'm just going to go ahead and open the Modeler app, and as it opens, we're going to see, as I expanded, an import button over here. I can either import data from my file that I'm currently in for the moment, or I can actually import data from the workspace. Remember, I did a bit of analysis beforehand, which makes it so easy for me to bring in data that I've worked on already. So S&P returns trend, I'm going to import over here, and here you have it, the same data that's available to me. Now, if I did bring in data that wasn't differenced, I can actually difference it or remove seasonal, log all of the transforms in my app itself. But I don't need to worry about that right now because I've actually done all of that. Now what we're going to look at is actually testing my data, right? I need to look for unit roots. I need to look if this data is stationary. So over here at the drop down, there's all these tests available to me, but I'm going to use the Phillips parent test for now. And it gives me all these parameters that I can change. I'm going to keep it the same, especially the significance level of 5%. And the null hypothesis tells me that my data contains a unit root. So hopefully it doesn't. Let's run the test and see. Click. There you go. I can actually reject the null hypothesis, which means my data doesn't contain a unit root. So let's go over to the modeler ribbon and bring down another test. I want to test for stationarity, just to make sure. Here, once again, I have parameters I can change. The null hypothesis says it's trend stationary. And then if I run this test, it says, actually, you can reject, fail to reject the null hypothesis, which means my data is trend stationary. So now let's go over to the app. And since I've done my tests, I actually want to look at my autocorrelation and partial autocorrelation plots. I'm trying to characterize my time series data. So here I have ACF for autocorrelation plots, which essentially is the results of my linear relationship between the time series data's lagged values. So here at the top, I can change the standard deviation, moving average, and lags. As I increase it, here you can see it just keeps going, but I'm going to keep it at 20. Okay. And then I want to look at the partial autocorrelation plot, which is the result when I remove the correlation effects of the shorter terms. Here you go. But I want to see them together, right? But this app allows me to move and change my tests and plots. So I'm going to bring this to the bottom. I'm going to drag and drop this banner over here, and I can actually look at the two plots next to each other. But looking at the two plots, I don't see any decreasing geometric pattern. There's no decreasing exponential pattern, no decreasing sine pattern, none of the above. Actually, I only have a significant lag at 1 over here and here. That means I can't use an AR1 or a MA1 model to define my values or my data itself. I actually think this data is governed by white noise, well, my returns data, which means my index is driven by a random walk process. So let me bring this back up and then go to the modeler and actually do another test. I want to do the Ljungbox Q test for autocorrelation in my residuals. And the data, the null hypothesis is saying that the first M autocorrelations of the data are jointly 0. So I'm not going to change the parameters again. I'm going to run the test, and it says actually reject the null hypothesis because they are not jointly at 0. I'm going to do another test. I'm going to try the Engel's arch test for heteroscedasticity. So basically, I'm looking for error variances of the sample. And I'm going to keep the parameters the same and run the test again. And it says I can reject the null hypothesis, which is that it actually exhibits arch effects. So I'm going to keep those in mind and actually look at my models. So I want to still create an Arima model, right? I want to go ahead, drop down the model, see everything that's available to me, but I'm selecting an Arima model first. I want to see if I can plot an Arima model. Estimate an Arima model. When it opens up, I have the model equation at the bottom. I have all these variables that I can change. My degree of integration I've differenced it, so I'm going to keep it 0. The AR is 1, MA is 1. See, the model changes accordingly. I have the innovative distribution that I can change. I can find the details, so I can open up the documentation in MATLAB to see about Arima model properties, and then I can estimate the model itself. So when I click it, what happens is I have a beautiful graph over here of the model fit, and then the residual part at the bottom, and all the parameters to the side that tell me that's available in my model itself. This p-value tells me how significant my data points, my parameters are, and then the goodness of fit is also available to me. We'll discuss this in a moment. If I want to look at my model a little bit more, I can actually plot other data, such as the residual QQ plot over here. And once I've done everything that I need, I can actually look at how to export everything up. I can either export the models to work on them, see, the Arima or like the train model. I can either create functions. So this will help when I'm trying to automate my processes. Now that I've known or seen what my data looks like, all the tests that happen, I can actually say, oh, look, I can create an Arima model. And if there's data that looks the same, I just need to use this function. I can actually generate a function to support that. Or what I can do is I can actually generate a report of everything I've done in the app. So if there's a situation over here, I'm just going to select and I'm going to either choose the report format, doc, HTML. I'm going to keep it as PDF. So I'm going to press OK. Over here, I've created it before. I'm just going to overrun this, save it as test. And essentially what MATLAB does is it creates a report for you. It looks at everything you've done in the app and puts it together in this beautiful report that you can either give to someone to explain what you've done, or you can actually record everything you've done. So maybe a few months down the line, 6 months maybe, when you have to revisit what you've done in the app, since you only have a function available at hand, you have this report that's available to you. So this 13-page document, if I scroll down, it shows you the table of contents of everything you've done, the data that we've used. If I scroll down, the autocorrelation, the partial autocorrelation plots, the tests that I've done, the outcomes, etc. So it gives you everything that you've done in the app itself. So let me close this. I'm just going to open the model over here, and then I'm just going to minimize my app for now. So let's go back over to the script. If I scroll down over here, you can see that everything I've done on the app, I've repeated it in my script. There's functions available for you. So if you prefer to use coding practices, you're more than welcome to repeat everything I've done in the app in your code. So PPT test, I'm going to keep my cursor over there, right click, press help, and open the browser. Before that, I just wanted to notice that there is a tilde. Tildes are to suppress outputs. So to explain that a little further, when I open up the documentation in MATLAB, I actually have access to the functions that I can use. It gives me a little information at the top, a description at the bottom, the input arguments, the output arguments. See, there's so many outputs that I can have, but if I don't want everything, I can put a tilde instead and just find the values that I need, in this case p-values, and then carry on. So there's all this information that's available to you that you can access over here in the search the documentation as well, or right click and open help. So I'm just going to close this quickly, and then here we see the KPSS test, the autocorrelation plots, partial autocorrelation plot. We tested for the LBQ, the Lingbox Q test, the residual heteroscedasticity, and the Arima model itself. One thing I want to show everyone is this p-value, 0.3661. If I go back to the app, the p-value is exactly the same. That just goes to show that everything I've done on the app, you really can replicate it in your script. So here we see the p-value over there, the AIC, BIC value, it's quite little, but remember they're not significant. So what are AIC and BIC? Let's refresh that as well. We need to know how good a model is at explaining the relationship between its variables, right? And the best way we can do that is by using information criterion. So remember there's two popular ones, AIC and BIC, the Kaike information criterion and the Bayesian information criterion. In essence, we're trying to find the perfect midpoint where the complexity of the data doesn't overpower the simplicity of the model, how well it explains the data, and vice versa. That's why the smaller the AIC and BIC values, the better. So what I'm going to do is actually look at how to make my Arima model a little bit better. So I'm going to iterate through all the possible options. I'm just going to use 5 for now. And when I find the minimum ones over here, I can see that Arima 104 seems to be my optimal lags. When I estimate it over here, create the model and estimate it, the p-value already for all these parameters are much less than when I did Arima 101. So keep this in mind. Let's just look at it for a second. If I scroll back up, see, they're much smaller than 101. So right now our best model is Arima 104. If I scroll down, even the AIC value is much smaller. It's minus 1.8807 instead of it being, let's scroll back up and see, minus 1.8804. So it's actually better. I can actually say my 104 model is better. Now test, right? I want to make sure that there's no artifacts, because the moment there's artifacts in my data, I might actually need to estimate an Gauch or an arch model. So when I do the test, it says, there seems to be artifacts in your data, so let's actually look at it. So from the test above, the data showed that there is conditional heteroscedasticity, which means I need to use my Gauch model to kind of encapsulate the volatility in my data. Over here, remember 2008-9, and over here at 2020, there's a bit of volatility in my data, and this can best be modeled by Gauch models, right? So when I look at my PAC or my autocorrelation or partial autocorrelation plots, I need to look at the squared returns, remember? So over here, when I plot that, the two graphs, yay, I actually have a decreasing geometric pattern in my autocorrelation function and two significant values in my partial autocorrelation function. So just from this, I can see that we can actually use Gauch and arch models. For the purpose of this presentation, we'll be looking at a Gauch model. And the first point of investigating a Gauch model is by using Gauch 1-1. So when I scroll down and I estimate Gauch 1-1 over here, and then I estimate it with my data over here, I can see that the p-value is much smaller than Arima 104. Already, they're so much better. And even the AIC is minus 2.09. That's so much smaller. So here, when I infer this data and I plot it against the returns, the inferred volatility spikes wherever there's changes in the returns. So just from this graph itself, I can see that my model, the Gauch model, is actually really good for my data itself, right? So what I'm going to do is I'm actually going to do one more step. I'm going to combine my Arima and my Gauch model together over here. And then what I'm going to do is I'm going to estimate this data with my training data and then see what I get. When I do that, my p-values are once again much smaller, but my AIC value is smaller than just Gauch 1-1 itself, which means as of now, the best model that I have is this combined Gauch Arima model. One thing I'd like to show everyone is that every time I enter the Arima function, I actually say a model 4, right? So if I open model 4 on my workspace, it's this beautiful encapsulated Arima model with all these properties, this metadata that I'd never need to go and calculate by myself, because MATLAB does everything for me. So all this metadata, all these properties, it's available to you. You can just open it, click it, and everything, you can access it so easily because MATLAB does all this calculation for you. When I estimate this model with data itself, I have a fitted model over here. If I open fit 4, once again, it's all this data that's available for me to look at, to open and to access, and I don't need to go and work this out separately because MATLAB does it for me already. See, there's multiple outputs as well. I've suppressed one that I haven't needed, and I've actually chosen everything that I do. So that's a nice thing about MATLAB. When you use models, there's a lot of metadata associated that's given to you because MATLAB calculates itself already, and you can choose the outputs that you want as well. You don't have to be stuck with so many variables if you're not going to use them. So now let's forecast my returns using the Arima Gauge model. Just going to run this quickly. And when I simulate this model with my fitted data, let me see what it looks like. That is quite interesting. The forecasted data seems to actually look quite, not very, but quite similar to the test data itself, right? The test data is what we have, and the forecasted data is what we predict that it's going to be. So the general behavior, it doesn't seem to be way off or way too little. But remember, we created this model in just a mere 20 minutes. We didn't do a lot of testing, we didn't do a lot of processing. That's how simple it is to work with MATLAB. You can either use the app to quickly make your models, or you can use the script itself and work through what you've done so far. So that's just a simple way of creating Arima Gauge models in MATLAB. So let's go back over to our presentation. To look at what we've done so far, MATLAB is super user-friendly. If you want to use an interactive method to look at your data, you can use the Econometrics Modeler app. And if you prefer using scripts and functions, you can replicate everything in live scripts itself. All the data is central, which means importing the data, processing the data, all happens in MATLAB. You don't need to use Excel to clean the data, another function to process the data. Everything is in one place. The key characteristics of the model are also provided to you. They're easily accessible. You don't need to calculate them in a different way because it's all available to you. And most importantly, you have automated reporting features that's right at your fingertips so that you can always keep count and keep memory of exactly what you've done. So thank you for coming to this presentation and Optinum's webinar series as a whole. If you have any questions regarding MATLAB or modeling in time series, you're more than welcome to reach out to me. My email address is malavika.nathan@optinum.co.za. Michelle will be putting through a link to a survey, an evaluation form, and once you've completed that, you will have access to the presentation, the code, and the data to run my code in due course. And in this presentation itself, you will have a link to the previous Optinum webinars if you've missed them, so you can revisit them, download the code, and work them through. So if you have any questions, you're more than welcome to ask them right now in the chat or unmute yourself and ask right now. I see Varush and Kupu, one of our other solutions engineers, have actually added the feedback survey in the webinar, for the webinar in the chat itself over here. So if you have any questions, you're more than welcome to ask or put them in the chat.
Hello.
Hello.
How are you? I'm sorry, it's not actually a question. I wanted to ask some question that I'm not is that good as far as country is concerned. My field of specialty is stochastic processes. How friendly is it to use MATLAB in stochastic simulation when you're simulating stochastic processes?
Sorry, I didn't hear the question completely. It was
I'm
breaking
saying
for me.
I'm not as good to as far as time series is concerned. My field of interest is stochastic processes. How good is MATLAB in simulating stochastic processes?
Right. So We are joined by Talita Foyun, who is our team leader in the FDS division, the Financial Data Science division of Optimum. So Talita, how easy are stochastic processes to be simulated in MATLAB?
Thanks, Malu. Hi, Tabani. It is very easy to model these stochastic processes in MATLAB. MATLAB is actually very good at this, particularly when you want to generate very large number of simulations. I know in other modeling languages or packages, it can be quite difficult to perform these simulations when you have when the number of simulations become very big. And MATLAB is particularly strong at coping with these and allows you to process the data that is generated by these stochastic processes very easily. We'll gladly share some resources or some examples on stochastic processes, Monte Carlo simulations, etc. With you after the session.
Okay, thank you. I'm really worried. I'll get if you share those resources with me. Thank you, ma'am.
Sure, no problem.
Right. So there are a few frequently asked questions in time series modeling. I'll just be going over a few in case anyone has a few questions or they don't necessarily need to know what to ask. We can always check what's... Sorry. Let me see. So the first two questions is, in which toolbox could I find these
Mali,
functions?
I see there's a question in the chat. Sorry.
Yes, thank you. Sorry. So the question in the chat is from Oluwafemi, sorry. So from the results, how do you suggest the accuracy can be improved, the hypothesis testing, or could the issue be with the data? So with the data itself, we can always assume that if we're working with S&P 500 data from the live source that we've inherited it from, it might not be the data's problem. We can always use other hypothesis testing methods or other other accuracy testings. So we have a consultant on the call as well, Taratiwa, who can actually answer that better. Taru?
Okay, thanks, Malu. So yes, the question is saying how can you suggest the accuracy, right? So as you can see what Malu has already done, we managed to test about 4 models, right? So we started with an Arima 111, Arima 101. Then we actually used the BIC and AIC to check which one is the best model to use. So you can also test the accuracy, like what you've already pointed out. You can also use hypothesis testing to check how good is our testing data, to how good are we able to fit our testing data to what we've already focused it. So yeah, I think you're right. You can also use hypothesis testing.
Let's see if there's other questions in the chat. You're welcome. So Talita, I'm going to ask you in which toolbox I can find these functions and the Modeler app.
Cool. So the econometrics modeler app can be found in the econometrics toolbox, all the functionality which the app is based on. These are the functions that Malavika showed in her script are found in the same toolbox. So essentially you have the flexibility of choosing whether you'd prefer to do this type of modeling in the application itself, or you can choose to do it in a script if you prefer coding.
Thank you. And I've also heard about timetables in MATLAB. Are there any advantages?
Yes. So in this example we looked at today, it was a univariate analysis, but I think there are many instances where you would like to do multivariate modeling. And one of the challenges in modeling multiple variables is often in the preparation of the data. You'll find that the timing of the data doesn't necessarily synchronize well, and some data might be captured on a daily basis. Other data may be captured on a weekly and a monthly, etc. And so getting this data to line up well so that you can perform your analysis can be not challenging, but often frustrating and time consuming. And when using timetables, there are multiple functions such as one called retime or synchronize that makes it very easy to capture all the data for various time series in one place and then get them to synchronize well together so that you can start your modeling.
Right. Thank you so much for that. Taru, I have two questions for you as well. What if I have existing models in another language? What do I do now?
Okay, I would say for me personally, it's just my preference. I prefer MATLAB. For example, here you've already shown the econometrics app that you can use. So this app, even if you don't know anything about coding, if you're someone who doesn't like to code a lot, you can actually use this app. There are several apps that you can use. So with apps, it makes it easier for everyone to get the results, everyone to run in Arima model, and anyone can do a Gauge model in an app without even understanding how to code, how to really do everything like step by step on a script. So that's why I prefer MATLAB in this case. But previously, I also worked on the time series models in SAS and other languages. But for me, I find it much easier when I'm working with MATLAB. Then for the next question of how good are time series models on evaluating the performance of an asset or something like that. For me, I think time series is one of the models, but it's not the only model that you can use to be able to predict maybe the returns of an asset or the price of an asset or something. So there are a lot of models that you can use, but the advantage of time series is that you can actually extract a trend. For example, you want to invest in an ETF or something, then in that case, you can actually be able to predict the historical performance of that ETF by extracting the trend that you have from the data. And you can also extract the seasonality patterns from that data. And another advantage of time series is that you can use the Gauge models to predict the volatility clustering. We all know what happens in 2020 around March, April. There was a stock market crash. And to be able, you can actually use Gauge models to predict that volatility clustering in the data in the future. So yeah, so that's what I can only say.
Okay. Thank you so much for that as well. So I'd just like to double check the chat to see if there's any other questions so far. All right. If you do have any questions, please feel free to reach out to us. We're more than welcome to help you with anything. And I'd like to thank everyone once again for coming to this presentation, and I hope you have a good week ahead. Thank you.
Thank you.